Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson. And today's lesson is one of the most important lessons you can ever learn in mathematics. It is about the Pythagorean Theorem, which many of you have probably heard. You've probably heard something like this. The Pythagorean Theorem is a squared plus b squared equals c squared. Now, I'm not going to use that formula just yet. I'm going to explain a little bit about what's going on here with the Pythagorean theorem and let you know it is extremely famous. It's named for Pythagoras or the Pythagoreans. There's some debate as to whether Pythagoras was a real person or if there was a group of mathematicians who just called themselves the Pythagoreans in ancient Greece. But anyway, it's actually extremely famous. It's probably one of the most important formulas you can learn in middle school level mathematics. And it's the beginning of the basis of engineering, and it's actually misquoted in the Wizard of Oz. At the end of the movie, the scarecrow, when he gets his brain, he misquotes the Pythagorean theorem. He says the sum of the squares of two legs of an isosceles triangle is equal to the square of the third side. And that is totally untrue. The Pythagorean theorem only applies to right triangles. But let's talk about proving it first before we start to see it, because anybody can just start to regurgitate it. And let's see what's going on. Let's say I have this square here, this 3 by 3 square. I'm sure most of you can tell me the area of that square would be 9 square units, right? And this square here is a 4 by 4 square, and most of you could tell me that the area is 16 square units. Remember, to do area, you do base times height. 8th graders, you're going to get a formula sheet on the OAA. 7th graders, you will not. So you need to commit these formulas to memory. Remember, not too long ago I gave you a formula sheet. You need to be memorizing them. Okay? Now, check this out. If I take a 5 by 5 square and I lay it right there, so the interior makes a perfect right triangle. You see my right triangle? I'll go ahead and highlight it right here. The right triangle is here. My highlighter's a little sloppy. Okay. Now, this is really cool. If you take the area of that first square, the 3 by 3, which is 9, and the area of the second square, which is 4 by 4, its area was 16. And the area of the third square, 5 by 5, is 25. And you notice that 9 plus 16 equals 25. That's the Pythagorean theorem in action. We just proved that it's true. That if you have a right triangle, 3 units long and 4 units wide, or you could refer to the height as 3 units and the base is 4 units, you square those, you will get the area of the third side. Okay, this is the Pythagorean theorem in action. It will work if I took, if my squares were, say, a 6 by 6 square. If this first square were 6 by 6, its area would be 36, right? And if the second square were 8 by 8, that would be 64. And that would mean the third square would be 10 by 10, which would be 100. And notice I get a true statement once again. There's lots of Pythagorean triples out there. Obviously, 3, 4, 5 is a Pythagorean triple. Why? Because 3 squared plus 4 squared equals 5 squared. It is a true statement. That's what's said right there. Okay. 6, 8, 10. Any multiple of 3, 4, 5 is going to work. I'm not going to run through those. There's lots of other ones, though. For example, there's 5, 12, 13. If I took a right triangle and it was 5 inches tall and 12 inches long, then the hypotenuse, the longest side of a right triangle, would be 13 inches. And I can prove it using Pythagoras. 5 squared plus 12 squared. If that equals 13 squared, then I have a Pythagorean triple, and this all works. 5 squared is 25. 12 squared is gross, 144. Okay, and 25 and 144 is 169. And sure enough, 13 squared is 169. There's other ones. I think 8, 15, 17 works. Okay, and of course, any multiple of these works as well. So let me see here. 8 times 8 is 64. 15 times 15 is 225. If I add those together, I get 289. 17 squared, sure enough, 289. You see they match. Okay, well, how do we use this? The first thing is, when we have a right triangle like this, now they will have to identify the right angle for you, and that is very important. If you're not sure, the right angle would be there. They have to identify it for you. They can either tell you that, give the letters, the angles, letter names, like they could call that A, B, and C, and they could tell you in the story that the measure of angle C equals 90 degrees. They could tell you that angle C is a right angle, or they could just give you this mark right here. Okay, those are a lot of different ways they could tell you that it's a right triangle. Remember, Pythagorean theorem only works for right triangles. Now, if I have a right triangle, I know that I can figure out the missing side. Now, please, please, please be careful. Remember, the formula is a squared plus b squared equals c squared. I have to warn you right now, I've been teaching a long time, and I want to tell you, C is not always the side you're looking for. You are not always looking for C. You are not always looking for C. Did I say that enough times? C is not always the side you are looking for. C is always the hypotenuse. C is always the hypotenuse. The hypotenuse is the longest side of a right triangle, and you will always find it across from the right angle. So I have my pre-algebra students always draw that little arrow in. If you think you're always looking for side C, you need to draw that arrow in. Okay, I know there's some of you who are going to do this wrong because you're always going to think you're looking for C. And I'm going to say, don't you remember me saying it 15 times? And you're going to say, oh yeah. All right, so just to prove C is not always the side we're looking for, I'm going to fill in, say, this side here. I'm going to call it 10 inches. And I'm going to fill in the side and call it 20 inches. Okay, and then I want to know the measure of side BC. I'll call it X. I'm going to advise you the first thing you do, fill in the measure of side C. If it's your variable, great. If not, fill in a number for it. I'm going to use parentheses whenever I fill in. Okay, now A and B don't matter. A could be 10 or A could be X. It doesn't matter. B could be 10 or B could be X. Obviously, they both can't be the same thing unless it's an isosceles right triangle. So I'm just going to put 10 squared here for A plus X squared for B. All right, and this is going to be 100 plus X squared, and this is going to be 400. Then I'm going to subtract 100 from each side, and I'm going to get X squared is equal to 300. Now, I know that I can take the square root of each side because of the lessons we've been learning recently. And I could run to my calculator. It depends on the context of the problem. But for today's lesson, we are going to go with exact answers. So I'm going to get X equals the square root. And I know that 300 is the same as 3 times 100. And I know that 100 is a perfect square. I can think about it as 10 times 10, which means I have a pair of 10s to leave the house and go on a date. So X is going to equal 10 times the square root of 3. And there you go. All right, now if I need a decimal approximation because I want to know about how long, then I'll use my calculator to do 10 times the square root of 3. All right, let's try another one. Let's look at one. Where's my right triangles? Okay, like this. And let me change the orientation of it. Okay, and my right angle is here. And this time I'm going to tell you that this is 7 centimeters. And this is 5 centimeters. Okay, and I want to know this side right here. Well, again, I use a squared plus b squared equals c squared. And the first thing I do is identify which side c is. Go to my right angle, draw an arrow, boom, c this time is the variable. I'll fill that in. Okay, I'll have 5 squared, use some parentheses there, plus 7 squared. Well, that's 25, and that's 49, and that's still x squared. And 25 and 50 will be 75, so this will be 74 equals x squared, right? And I'll take the square root of each side, or the rad, because I only care about the positive square root. And I've got x equals, now I'm going to break 74 down. I'm not thinking that 4 goes in. No, I know 2 goes in. 2 is going to go in 37 times, right? And 2 is prime, and 37 is prime. So I cannot get a pair to leave the house. So my answer is the square root, or excuse me, the rad of 74. Now, let's use a skill here. Let's think about the square root of 64. I know that that is 8, right? And I know the square root of 81 is 9. Now, some of you are immediately going to go, 8.5. No, it doesn't have to be 8.5. Let's think about this here, okay? Let's go 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. Okay, so let's find the median, the middle number of this data. And I'm going to put a little mark in the middle here. Maybe I'll even use this one, it's more pronounced. So let's see here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the middle is going to be between the 9th and 10th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle is going to be right there. And I should have the same number on each side if I did my counting right. 2, 3, 4, 5, 6, 7, 8, 9. And over here, 1, 3, 4, 5, 6, 7, 8, 9. So there's the middle. I could expect that the decimal 8.5 would be halfway between the square root of 64 and the square root of 81, which would be like about the square root of 72.5. Now, it's not going to be exactly that, but it's going to be right around there because we're dealing with irrational numbers here. Okay, so the square root of 74 is a little bit more than that. Now, you can't just say 8.6. Let's test it out, all right? So let's find the median of this second half of the data. Well, we said there were 9 numbers there, so the median number would be the 5th one. 1, 2, 3, 4, 5. All right. This number here, the third quarter of this data, I would expect to be about 8.75. And again, we're dealing with irrational numbers, so it's only going to be approximate. So what's halfway between 8.5 and 8.75? Well, it should be 8.625. And so, by the way, if you're wondering how I did that, 75 minus 50 is 25. Half of 25 is 12.5, right? So if I do 8.5 plus 1.125, that's my 12.5, see? And then I get 8.625. So about 8.3 or 8.625 is more exact. So 1, 2, 3, 4, 5, and that makes this 8.625. So 8.6 would be a pretty good estimate. That's actually here, sorry. This would be about 8.6 would be a pretty good estimate. You can check that on your calculator, square root of 74 or rad 74, and you should get about 8.6. All right, so yeah, x would be approximately 8.6. And I only did that to show you how to estimate. Okay, so that is the lesson on the Pythagorean theorem. We did one problem where you're trying to find the hypotenuse, and we did another problem where you know the length of hypotenuse and you're trying to find another side. All right, Mr. Lawrence signing off. Good night, everybody.